of a reel, you have this kind of stuff. Yeah. Right, this kind of stopper. So it's actually a spring and damper in there. These are the real way. You can download this kind of app. So there are three parts to this. Let's have a look. And we'll really finish all the parts here. Do you have class after this?
Yes.
What time?
4.
20 minutes. Okay, I'll try my best. This one says that the train is coming to the real wave buffer where it has a spring and a damper and a mass. That reel is approaching at a velocity v, right? So its velocity, I put it small letter v. The capital letter V is written in that way. Small letter v, I have just one side of it. So what we are going to do is to let this small letter v be the velocity of the combined mass after it hit each other. So this mass, capital M plus small letter m. This is the combined mass after impact. So after impact, they stick together with each other. Right? That's the assumption. So by the conservation of momentum, this relates to your physics. So that capital M, capital V will be equal to combined mass M plus small m multiplied by that small letter v. Right? That is your conservation of momentum. So I can express small letter v now equal to m v over m plus small m. And this is short. If you're able to show that, 1 mark. Yeah. So this kind of like before impact. This is after impact. So before is equal to after impact, the momentum. So I know in previous questions we saw using your static condition followed by dynamic condition. So because you don't have enough time during your exam, it's just 2 hours. So I'll teach you how to go straight to dynamic condition. Both cases marked correct. First foremost, you need that schematic diagram. After they hit each other and combine the masses, they're going to oscillate. Right? There's a spring damper, they're going to oscillate. That spring and damper, both of them would be compressed. Right? So there's equal and opposite force for the spring, which will give you Kx force, that's the spring force. And then the damping force is Cx dot. That's your damping force. If you are able to sketch this free body diagram, 1 mark. These are allocated marks. So if you don't write it down over here, this schematic diagram, and prefer to sketch on your hand during exam or your free body diagram, then you lose that 1 mark. I can see your hand. 1 mark. So please write it in your exam script, not elsewhere. So after that free body diagram, summing up the forces along x direction, that's big mass plus small mass multiplied by x dot dot. This is your Newton's second law. So since these two arrows for the damping force and spring forces are in the opposite direction of my convention x, that means both terms would be negative. M plus m x dot dot. So I can express it into the following form. m plus m x dot dot plus cx dot plus kx equal to 0. And if I divide throughout by m plus m, that means in that way, x dot plus k m plus m x equal to 0. If you're able to do that, you get one more mark. I call this equation as equation 1. And we know that in this exam question, it has a damper. So for damped